Hello folks, and welcome to part 3 of our SGAM Toolbox video tutorials. In this tutorial I'm going to show you how the SGAM Toolbox can support you during the security requirements engineering task. But before we start modeling, let me say a few words about the underlying theory to better understand the implemented concepts. So when we are going to analyze some security issues, the central element is an asset that can be attacked. To be more precise, every asset has certain vulnerabilities that can be exploited by an attacker. So we say a potential exploitation is a threat, and an actual exploitation is the realization of a threat, or in short words, an attack. As we want to make an attacker's life as hard as possible, we're interested in some countermeasures in order to mitigate the vulnerabilities. Basically, these countermeasures are the realization of the security requirements we're interested in. To make the concepts a little bit more clear, I'm going to show you the underlying conceptual framework. So here in the center we have the security asset, which has some vulnerabilities. These vulnerabilities are potentially exploited by threats or actually exploited by attacks, which are the realization of threats. These attacks itself are executed by an attacker. What we are interested in is to mitigate the vulnerabilities, so we want to have some countermeasures which in fact realize our security requirements. Engineering these security requirements for every single asset is a quite extensive task, so we are looking for possibilities to make our life a bit more easier. And one thing we can do is to create patterns for security requirements and apply them to similar assets, and therefore we first have to categorize our assets. The categorization of the assets can be done on the basis of the possible attacks. So if we take a look at the image here, we can see clearly that attacker can attack a system itself. So we have the system asset here and here. Then an attacker could possibly attack the communication between two systems. This is this one here. And of course, before one of these two attacks could be executed, an attacker needs to get access to the interfaces of a system or a network. And so we have the last asset, the network communication. Based on these asset categorizations, we can derive some general patterns for every category. And these general security requirement patterns reflect the four-layer security strategy, which comprises of policy, technical measures, detection, forensics, and containment. If we take a look at the underlying conceptual framework again, here we see now it is extended by these three elements, which in fact realize a security asset. So we have a system, a network, and a communication. And each of these elements has its own security requirement. So we have system security requirements for the system, network security requirements for the network, and communication security requirements for communication. And all of these specific requirements generalize the security requirement. Here we see that this security requirement itself consists of 4 types of requirements. So these 4 types reflect the security strategy with policy requirements, technical measures, detection, forensics, and containment. So to be more precise, each of these requirements here is reflecting one pattern, and so each of these requirements is built up of numerous requirements reflecting this strategy. So each of the sub-requirements in fact can be mapped to one of these 4 requirement types. As we learned now, we are able to instantiate individual security requirements from patterns for every single component based on the type of security asset that is realized by a component. In real-life projects, of course, this is not enough, so we're interested in transformation from these general requirements into more specific and individual requirements. Like, for example, we want to turn the general requirement authentication into a specific requirement which says authentication with physical token and PIN. And these refinements are based on the individual risk that one single component faces. If we take a look in the meta model first, we can see now here that it was extended by a risk, and this risk is determined by two main components. On the one hand, we have some potential loss or harm that is associated with a security asset, and on the other hand, we have a likelihood which gives us information about the probability that a successful attack occurs. What we did now for the calculation of the risk is we created a simple formula which could be used as starting point for your individual considerations. So this formula basically considers the two factors potential harm and likelihood. So the potential harm here is given by two terms. The first one is taken from the M490 working group, Smart Grid Information Security, and here we're using the security level, which is directly related to position within the SGAM plane. And the second factor we introduced is a factor 2 by the power of direct operational effects, which should mention if there are direct operational effects to expect by an hacked asset. The second factor here, which is representing the likelihood of an attack, is a little bit more harder to get. So we tried to get it by introduction of some attack probability indicators, which should help us to indicate the likelihood of an attack. So we determined 3 element indicators. So the first one is the motivation of a hacker, the second one is the reachability of an asset, and the third one is the propagation of secrets. Please let me turn your attention at this point to the document Introduction to the SGAM Toolbox, where all these considerations are explained a bit more in detail. Okay, and that's enough with theory. Now let's turn to the praxis. And just to sum up, what we're doing in the model, we have to execute 3 elemental steps. So the first one is we have to identify the security assets and instantiate the general security requirements from the patterns for them. Then we have to assess the individual risk for every component. And finally, we individually refine the security requirements for every component with regard to the individual risk. Okay, now let's start modeling. Okay, I now have opened the model from the last video tutorials. And the first thing I do is I create a new package which I call security requirements, just below my model. Okay, say it's a simple view. Just organize it below. Then I create a new diagram. Here I select from the SGAM Toolbox the security requirements diagram. Okay, here we go. And what I do next is I navigate to the component layer. Here we have, just open it. And here I'm going to copy all the equipment I want to analyze. I just copy it, move to the move to my security requirements diagram, and just paste my elements here. Okay, then I want to see all the ICT connections and the communication paths. Okay, I just delete, to make the example easier, these elements, and I just focus here on these 2 components and the connections. Okay, I said I want to see the communication paths, so I make them visible. Say diagram advanced visible relations. Here I select my communication path. Okay, just a little bit of rearranging. Okay, and now I'm going to analyze this diagram, and I try to identify which assets I have and which assets I have to take care about. So I see 2 systems, 1 network and 1 communication. So what I need now is I need security requirements for each of these assets. So here I take the system security. I have one for the DMS, system security, which is here, Then I have one for the EMS. Okay. Then I have one network security. Here I take the network security element. Okay. I don't know how is it called. It's FL network. Okay. Okay. And the last one is the requirement for the communication asset, which means this and this component are affected from this. So I take the communication security. Here we have. And now it's between the distribution management system and the energy management system. Okay, the relation between them is a realization. Sorry. This way around. Here we have our realization, the network security, okay, and the communication security. Okay. Okay, and so we basically have our our 4 requirements for our 4 assets, which we want to use, and we want to apply the according patterns. In the next step, we want to instantiate the according requirement patterns for each of these 4 requirements. So let's start with the DMS system security. So the first thing, I just copy this element to the clipboard. Then I open the underlying diagram. Sorry, my double click is not working during the video recordings. So it's the system security element. This one I want to open. Okay, I just paste it here. And now I want to apply the complete pattern to this one requirement. So I say this is a system security, so I want to use the system security requirements pattern. I just drag this pattern here to the diagram, and then I can say that I want to have the pattern merged with this one requirement. So the pattern is linked to this one requirement then. So I'm going to browse to the top level requirement here, it's system security. Here it is. And I say don't create this element, but instead merge it with the existing DMS system security requirement, which is here. Okay. Please look at the left side here, and then you will see how the patterns will be created. So they are instantiated as new objects. Okay, here you see. Okay. And here we have the pattern now, all the elements from the pattern. Just resize it a bit. Okay, like this way. So, okay. And here we see that this is our top level requirement, the one we created, the DMS system security. Just change the title to DMS system security requirements. Okay. And we see now that this requirement consists of a number of sub-requirements, which finally lead us to these requirements, which are associated, they're color-coded to the security strategy. This means they are whether a policy requirement, a technical measure, a detection forensics, or a containment requirement. I just insert here the related elements to make it clear to which element these requirements belong to. So it's the DMS system here we have related to. Okay, just leave it here, no matter about this. Okay, so that's how we instantiate the pattern for one of these requirements here. After having the general requirements instantiated for each of these requirements, we want to transform them into some individual and more specialized requirements. And so what we need to do first is we want to assess the risk every system here is facing. So I simply create one risk for each of these assets here. So we have this is DMS system security, then we have communication security for DMS EMS communication security. Next one we have the FL network security, and finally we have the EMS system itself. Okay, we just link them to the appropriate elements. Okay, communication is with both. Here we have the network. Okay, if we take a little bit closer look, we can see that all these risk elements have the appropriate factors from the formula as presented in the presentation first. So we have hacker's motivation, asset reachability, and propagation of secrets as attack probability indicators. We have ASCII security level and direct operational effects as indicators for the potential harm or loss. And finally we have the calculated risk, which is resulting from these elements. We could now open one after the other here. Sorry, my double click again, a little bit annoying. And in detect values we could do it manually for each of them to enter the individual values. But if you have many more elements, this is a little bit annoying to do so step by step. And what we can do to make it easier is we can export all the risks to a CSV file. So with simply open project, model import export, select CSV import export, and here we have integrated a short CSV template for the risk. So we select this one, we just select the file where to save it. Here we browse to the desktop and call it risk assessment. Okay, just save it here and say export. Oh sorry, have to say export. Okay, and here we see all the risk elements are exported. And what we can do now is we can start Excel. Okay, so we open the exported file. So here we saved it on the desktop. It's called risk assessment. Okay. And here you see all the fields from the element. So we now could manually enter here the values and then maybe manually calculate the risk or create a formula or something. But to make it easier here, I prepared a template, so we just copy the names. Okay, I open the prepared template, which you can download on www.en-trust.it. Okay, just open it here. It's an Excel file. It's called risk assessment. Okay, open it. Okay, and here I simply paste the elements. And now I can prepare it in a more comfortable way. So for the attack probability indicators, I will enter values between 1 and 3. I've chosen to take only these values because by having only 1, 2, 3, you have a higher probability that different people will deliver the same results. So let's say the hacker's motivation for the DMS system is very high. The reachability is very low because it's only in a restricted room available. Propagation of secrets low again. Security level, I don't know, I think it's a 3. And direct operational effects, of course. Then the communication between DMS and EMS. Again, I say, or maybe here I say it's maybe a 3. The reachability is a little bit higher. Then we have propagation of secrets higher again. Here we have the highest value, a 3 again, and a 1. The network is also very interesting from hackers. Reachability is 2. Propagation of secrets, say 2 again. And of course, if this network could be hacked, I could gain access to the DMS, and so I have 3 again here, and direct operational effects. The EMS system security is a local system, so it's not that interesting. Reachability is high. I just give it a 1 here. Propagation of secrets, not too many people have access, so it's a 2. Security level, I guess it's a 2 here again. And we don't have operational effects to the electric grid, as this is only a local system. Okay, and here we get the indicated risk calculated automatically. Of course, I did this quite fast now, but of course you should perform more considerations about that. So now I can copy it again, going back to my original CSV file, just paste my created values. Okay, then I can save this file. Yes, as CSV file. Just close it, don't need any more. CSV. This one I don't want to save. And now I can re-import the values. So again, project, model import export, CSV import export. Here I use my risk script again. This time it's an import. Select my file, CSV, okay, and I say please import it, run, okay. And actually now we don't see anything here in the diagram. This is some update issue, so I close the diagram again and open it. Open. Okay. And as you see, we have all the values and the calculated risks now associated with the components, and based on these informations we can start refining our requirements. So I open the requirements again, my annoying double click, open it here. I just want to see it in this diagram, so I say please show the linked elements. I want to see the risk. Here I created the one for system security, and of course I have one for communication security. Okay. Well, I'm interested in the tagged values as well. So I say please show me the tags. Also this one. Okay. Don't mind the layout. And now I can start and browse through these diagrams, browse through these requirements and adopt them according to my calculated risk I can see here. Please take note that all of these requirements here, they are just the first version of a pattern, so we they are inspired by the security requirements from the M490 Smart Grid Information Security Working Group and from the requirements from the German Bundesamt für Sicherheit in der Informationstechnologie. But that's not the last version, so we are still working on the requirements pattern. We're going to adopt them, and in the next release we want to integrate the requirements from NIST. But of course, if you have your own collection or if you have some feedback, just send me an email. You also can send me maybe your own requirement patterns or your own requirement collections, and I can integrate them into some patterns or into these patterns if you want to. Okay, after we've done this and we integrated the requirements to our model, we can use all the integrated features to manage our requirements. So for example, if we want to see all the requirements, we can use the search function. We say project search. Maybe we open the builder and create a new search. Call it all requirements. Okay. Then we add a new filter, and we say we want to find all objects of type requirement. Okay, I can't use my double click here, so I just say yes, and here I can change the search term. I say all elements of top object requirement. Okay, and run. Sorry, I need of course say it's required, mandatory, so run. And now we get all the requirements, and we can use this list for getting an overview. So with which state they are implemented, approved, we can edit them. We can say this one is now it's turned to mandatory. I can leave my notes here, why it turned or something like that. And there are many more features. We can group according to the stereotypes, so we get here the detection forensic requirements, the network security, policy requirements, and so on. If we move to the top, we see that we also get the business goals here, because they're also of type requirement. So we want to edit our search. We say options, manage searches. Oh, sorry, it's the wrong one. Here we say options. Here we can say please return only matching items for the selected package, and so run. And now I only get the requirements which are placed in this package somewhere, and here I can track them in a way I want. Something that's also very useful is to work with the model view window here. We just make it visible, and here I can place my sorry, I have to remove this one yet. And here I can create my favorite searches, or I can example create my views folder, add new search folder, then I say it's all requirements. In the package, for example, I select my search, it's the all requirement search. Okay, and here I always get the overview and can maybe say please show me in which diagram this requirement is, and here it is, intrusion detection. Okay. If you take a closer look to the security requirements, let me open the diagram here, then you will see that here in the bottom is a process element which is related to some of the requirements. This has the following purpose. So during security assessments, we have some assessments when we don't want to evaluate all the requirements, but only a few which are indicated here. And then we want to have checklists for the assessment. Then we can do the following. We just make the this element here composite. Say composite, okay. Just copy it to the clipboard. Open the new diagram. Insert it here. Okay. And then I say I want to have a checklist for all the related requirements. And maybe the checklist should also comprise the assessment for this system security. And now I also place this one here. Okay. And now I say please show me all requirements necessary for that. Insert related elements, all requirements please. Same thing for this one here. We had an auto layout in the diagram. Insert them all. Okay. So we get an ugly diagram, but never mind. We say please give me the list view. Okay. And here we see all the requirements which are related to these two periodic assessments, and out of this list we can easily generate a checklist to browse through something like that. Okay, that's all for now. So I hope you enjoyed and you think it to be a bit useful during your work. And if you have any questions or suggestions or inputs, or don't know, maybe you have complete requirement patterns you want to tell us about, then just feel free and send an email to me. You can find my email address on our homepage www.en-trust.it. Bye.